Had some technical difficulties there, but I'm back with the big conclusions from Module 2 project. Let me just check the stream and make sure we have audio, video. Module 2 project. Let me just check the stream and make... So that was kind of dumb. There was a plus button where I could zoom in, but I figured out I can hold 2 buttons, zoom in, zoom out. So you can zoom way in, zoom way out. But live and learn. Sorry about that. It's always fun using some new technology, but when you're on the bleeding edge, sometimes you do get cut. Okay, so I have a model. I can make predictions with the model. I could extend this out into the year 2050 if I wanted, based on these 4 years in the beginning, kind of the second decade of our 21st century. And we can see like it doesn't really make sense to keep extending it even further. Usually these kind of models are done for like a day or two. Like doesn't make as much sense to extend it this far, but it's kind of fun to see like how well this thing performs. And some quantitative information of like, is this a good model? Because at the end of the day, that's what people want to know. Like, you did this work, you did some math, you did some programming, you have this Python code, you have these nice plots. Is it good? What would tell you that it's worth using? So here I'm gonna make, so is it good? Accuracy. How accurate is this model? In 2014, and I'm just kind of listing is, let's say, and you know what, since I have so I have like price model average and I have Google data, why don't we just plot that? So I'll take my price model average and subtract it from my Google data, the opening price, because that's what I'm trying to predict. So in 2014, that was kind of the lowest error. And if I want, I could say, let's look at absolute value, because I don't really care if it's plus or, well, I guess better to be more than less. So in 2014, for the first few months, is less than $20 to $30. Accuracy in 2017 is over 700, it goes up to 800. So let's say $750 to $800 error. So the main thing here is we're trying to take what are the there's lots of ways to describe this, of like, oh, this graph goes up, then it comes down, then there's a spike. But what are the quantitative things, like as an engineer, what am I looking for? So one is accuracy. Another thing that I'm looking for is like, what is the precision? Like this error bar keeps increasing and these lines keep getting farther and farther away from each other. So this random walk keeps going higher, meanwhile this one keeps going lower, but the average price change is still, for both of these, it's a still average price change where it should be somewhere up here. So what are those error bars? So we could look at that too. Let's grab this. And now I can see the standard deviation. For the most part, it just keeps increasing. So every month and every year, we have bigger error, like less and less precision. So precision in 2010, standard deviation is 10 to maybe $50. Well, 10 to $100. Let's say early 2010, 10 to 50. Let's say first 6 months, $10 to $50. In 2017, standard deviation equals $450. $450 is half of the error that we're even predicting. So it could have been 800, or it could have been, we could have predicted 800, or we could have predicted like 350, right? Like it could have been a lot less, or I guess 250 down here, 250. So the error could have been a lot less. We don't really know because our model, we don't have a very precise model. We have a very accurate model, at least for certain days. And then we have a very imprecise model for other days. And I mean, here, if we had used more of this data in our training, then it would be different. But that's just, I don't know, that's the way things work. But this is, and kind of saying like, so the caveat, so when you're talking about like caveats of this method, these are the numbers that you can use to kind of just either justify or say like don't use it, like it's not worth using. So something like say something useful about it, but main thing is what are the numbers, like how do the numbers back up what you're trying to say. Yeah, and here are some other ways of talking about. Oh yeah, if you're using these dollar signs, you got to do this one. I forgot about that. A slash dollar. Otherwise, it thinks it's a LaTeX equation, which is fine if you want to use LaTeX. Did I forget one? Dollar? No? Oh, 2 slashes, that's right. I always forget about that. There we go. So now you get the dollar sign in that markdown. Cool. Anyway, so that's kind of, and for the most part, like first step is just get the thing to work, right? Like once you have a model, it's like, all right, great. Now I have something. It works. Next step is what am I going to do with that information? And for stock market, the main goal is make some money. So you got to say something about like how accurate it, like if you're investing with this kind of thing, how accurate is this going to be? How precise is the measurement? Yeah, and those are 2 main things. Then the caveats, so some people had maybe like with AI had generated like why there were drops in this price. So if you're going to do that, that's great. That's even better. Like, it adds a caveat here, but make sure you have like some information, like a resource to back that up. You never want to trust what an AI is telling you unless it actually gives you a reference that you can go check the information in. Cool. All right. Thanks a lot. Keep up the great work, and I will catch up with you next time.